Hello, my name is Nigelargriffiths. I work in Power Systems Advanced Technology in Europe. In this movie we'll be looking at getting started with PowerSC, that's Security and Compliance, and the Trusted Logging module. This came out in May 2012. So why do we care about logging? Well, those nasty hackers, or we should call them system crackers these days, will try and hide what they've been up to on our machine. And then they'll try to edit or delete their log records, even trash the entire disks to hide what's going on. All we'll see if they do that is the machine suddenly disappears, and when we try to reboot it, it won't do, and we'll have to go and get a backup, and we'll have no idea what actually happened on the machine. So if we need to get these log files off our machine to a safe place as soon as possible, then at least we can find out what was going on before we lost the machine. Well, this is where the PowerSC Trusted Logging comes in. It actually does this without a network, which is a pretty neat trick. But this isn't a session about general AIX logs, system logs, audit logs. We'll do a little bit of that as we go along. I'd like to thank Morten Vugmo and Garrett North for some of the information used in this presentation. There is an IBM website that covers PowerSC, but it's very much of a high view of what's going on and no hands-on information that I can be found in there. Except now we have the PowerSC Redbook, and Chapter 5 is about 70 pages on this logging feature. Now, big warn though that the title of this Redbook is rather odd, 12 words of fluff before it gets to PowerSC. For trusted lock-in, the prerequisites are the virtual I/O server 221 or higher, AX6TL7, AX7TL1. When I'm making this movie, at least one more technology level has been out, and don't forget all those service packs. If the hardware will run these versions, then you can run the trusted logging. There's no hardware restrictions. For information sources, already mentioned the Redbook. There's also some pages in the PowerSC documentation and the virtual I/O server, where this is all implemented. By default, AIX will do its logging to the local disk, and of course then we have the risks of the hacker removing these or destroying our system, and will never work out in a post-mortem analysis what happened. We can also add features to AIX so that it logs remotely over a network to some sort of log repository, typically another logical partition. Some of my customers like the open source syslog ng. It's nothing to do with nigelargriffiths. I think it's next generation or something like that. The logs are then saved in the log repository. This makes it very much harder for the hackers, as they have to break now into the log repository as well, which probably has very few ports open and is fairly well locked down. Some people then have commercial products that do some sort of log management. They'll be using some sort of archive onto tape because they can build up to be a large size, and they may be doing some filtering and alerting so that if they see common things happening in the log files that look like an intrusion or somebody repeatedly trying to guess passwords, then they're alerted and they can go and take proactive action. Here's my architecture diagram of trusted logging. Our client here, AIX, is running its login to the local file system, and it's going to use a virtual SCSI connection to the virtual I/O server. Now, we're using one of these already. If we're using any of these sorts of technology, we've got a logical volume out of the volume group on the VIOS server is our disks, or a whole group has been passed over. We're using file-backed storage, or even a LUN, and then using virtual SCSI to get that to the client. If we're using shared storage pool on a logical unit or virtual tape and virtual optical, then we'll already have a virtual SCSI connection. The only case where we won't have is that when we're only using MPIV LUNs over a virtual fiber channel connection. If you're in that particular case, then you will have to add a virtual SCSI interface and connect it to the client and the virtual I/O server. Everybody else can use a pre-existing virtual SCSI connection, because we'll take that data from the client, copy it into a device driver on the client. This will actually magically move the data across the virtual SCSI connection to a file system in the virtual I/O server. We go back to a larger picture with many copies of AIX in here. We're logging to local disks, and we're using this new trusted logging to get the data to the virtual I/O server. Now, because this is fairly unique to AIX, this means that most hackers won't be aware that this is actually happening, or realize that the logs are actually being saved to something called a virtual I/O server that they may not understand anyway. This will be 1,000% better than doing nothing in case we're going to lose a particular copy of AIX to a hacker. In addition, we could then connect our virtual I/O server to a logging repository. This means that we only have to set up this connection to the virtual I/O server instead of all of the individual copies of AIX, and this can save us quite a lot of work. We can then also have the filtering and alerts and the archiving as we saw before. So here's the command that does the bulk of the work, make vlog. We have the -name parameter just to give it a name so that we can find it and understand what's going on. We have a client name, which is normally the name of the logical partition, and then we give it the V adapter for the virtual SCSI adapter that's connected to our client. If you miss out the V client and the virtual SCSI adapter is already connected to a logical partition, you can actually work that name out for itself. Here's an example, or three examples at the bottom here. We have my log, audit, and system log. My client logical partition on my red machine is called red3, and here's the vHost adapter for it. And each time I run this command, it says it's done. It gives me a great big hexadecimal name, and it's VT log 0. We get 1 and 2 as we go along. It really is that simple. So apart from the virtual devices we created, we actually get a few files, and this is where the data is going to appear. They all appear in var VIO vlogs. If we go into there, we find a directory for each of the clients that we've connected to. There's a config directory which we're not meant to go and have a look in, it's private data. If we go into that directory, we see here the names of the three logs that I created. There are three directories. If I go into one of these, then we find that we have this, the red3, the audit name, and a state file, and some of them have log files. We actually end up this hierarchy then, red3, audit, my log, and syslog from the three names that I gave it, and in here we have the state file, and when data has arrived we actually have the log file too. So for each log file they look like the LPAR name, then the log name, and a generation number. In a little example in here for red3 and my log, we have two files that end with a number and one that has state written in it. These first two are the log files. They can be binary log files or text format files. It depends on the data we're actually putting into the log at the client end. The default is that you have two 1 megabyte files. So here's my 2, 1 and 2. I can ask to have more, then this number will go up to higher numbers. Once we fill the last one of our set, it'll go around and start overwriting the first one. The state file is used to work out things that happen to the state changes in the log files, and particularly when it switches from one log file to the next. So by looking in there we can find out which is the current log. Well, we've seen the make vlog command. There's also a list vlog command. If we just type in by itself, it gives us a list of all our log files. I've only got 3 set up in here. And remember this number here, the 5254, that helps us make sure we know what we're doing when we get to the client end. You'll see this is in vlog 0, the first one we created. If you put in the -d option, you get a whole bunch more information out in here. I've shortened this great big unique ID to make it fit onto the screen. And we can see down here that there's 2 files for the log, and it's 1 megabyte each, and there's 2 files for the state files of 1 megabyte each. And then there's one paragraph like this for each of the log files. We have 3 at the moment. We have been using the default repository for our log files, and we have an ls virtual log repo command, repository command, to find out the details of the various repositories. If we look up here in the storage pool, there's this blank name in here. This is the default, and we've looked at it. It's gone into var VIO vlogs. This virtual I/O server has a shared storage pool called Atlantic, and so it's pointing out the fact there's an alternative virtual logging repository to actually put the data into that shared storage pool. We'll look at this later on as an advanced feature. If we use the -detail, then we can see this is the repository. If we just create a virtual log in that repository, which is the default, then the default sizes for the files and the state files are specified in here. We could change this so that whenever we create a new virtual log, it will pick up the defaults, or when we create the virtual log, we can override the default values. It's saying down in here for the shared storage pool in here, this is the directory it's going to save the data, and again it has a different set of defaults, so we could make these two things different. Now let's move to the client AIX virtual machine. We're going to go and find this new device that we created. Just as if we put a new disk on a virtual SCSI device, we run the config manager command to go and find that. If we just created the virtual machine, it would have done this when it first booted up. As the root user, rather than padmin now, we're going to use the config manager, and it's saying, hang on, there's some device in here that I don't understand, and oops, Nigel forgot to add the PowerSC package, the virtual logging, on the client virtual machine. So we can go off and do that. We have to find the right device drivers in the PowerSC media that you've probably purchased. We're looking in here for the Power Standard edition in here, and the vlog driver, saying virtual logging device software in here. We add this and click OK. It takes a couple of seconds just to install this special feature. Now when we run the config manager here, I'm saving the before and after details of our configuration and running config manager in between, and it's highlighting here that it's found 3 new devices, vlog 0, 1 and 2, and these match up to the 3 device drivers, the virtual logs that we created on the virtual I/O server. If we use the ls-atra command, -EL and a vlog, we can actually find, there's our magic number that matches up with the unique ID on the virtual I/O server, the 5254. So we can directly work out which is connected to which. Now when you first create these things, they do all match in the right order, but if you deleted them and created them, you may have to go and double check that you know which one is which, because it's not obvious on the client end that vlog 0 is actually which one it is. And if you're actually looking down in here though, it actually says this is the mylog one, so you can actually find the details if you look in the attributes. You'll also find on AIX you have these new device drivers for the vlog 0 to 2. Not very exciting. So we're all done then, aren't we? And we have AIX logged into its files. We have a vlog device here running across virtual SCSI. It will arrive in the virtual I/O server. This is already set up to save into specific files so we can go and find that data. But no, there's 2 gaps missing in here. First of all, we have to tell AIX to not only log it to the local file system, but to also log the content to the new vlogs. Then we need to go over to the virtual I/O server, make sure we can actually read the logs out of the files that's saving there. If you're really into logging and you do this all the time, then you'll know the commands over here. I get a bit rusty, so I'll remind you how to look at those log files. Let's use our first example of the AIX audit log. This is controlled by this file, etc. security audit config. We'll go and edit that file, look for the bin section. These are the 2 files that it uses by default for outputting to the audit log file. We're going to add then down here virtual_log equals vlog and the vlog with the right number, which is our audit log number. Close that file. We're going to run audit shutdown audit start. Warning there that by default it doesn't start, so you'll have to put something in one of the startup scripts. One little warning there that the documentation tends to use vlog 0 all the time in every single example, and it gets a little bit confusing. In our example, the audit was vlog 1, so we're using that number instead. You'll find that the first one will work if you use vlog 0. If you then connect to a different logging system and try and do it again, it'll actually fail. It won't actually tell you that it's failed. It will silently put that into the error file, and if you don't notice that, you won't notice that the logging is not happening at all. On the AIX side, I forgot how to do this, how to actually read an audit log file. We're in the audit directory. Here we can see the bin2 that's outputting the logging information to it. We use the audit print command and just input the file, the log, and then it gives us all the details. This is because the audit file here is in some sort of binary format. We have to use the audit print command to actually get it out in text. On the VIOS server, we're going to go and try and find our copy of the file that's now coming over the trusted logging. var vio vlogs, the client LPAR name, and then the log name in here. If we look at the files in here, the state file is text, as we know. But it says that the 2 log files are data international. This means that they're binary. You get into real problems if you try and list that onto the screen. Now we're going to use this audit print command to do that, but which of our audit files should we be looking at? Well, if we look into the state file and look at the end of it, it says here this is now using the red 3 audit 0 file. So it's done a switch now to using the first one, the 0 file, and then we use that file as the input into audit print, and when we get the latest things that are coming out of the audit log. Let's now have a look at the system log side of things. Different file in here, /etc syslog.conf. There's a lot of text at the top in here describing what you can put into this file. I'm just giving you one example that collects quite a lot of information in here. So if we look at star.info, this is for all the facilities that are giving us information. Anything from information severity level of info or more detailed will actually appear, and it's just going to get copied into the /dev/vlog2. Note in here that some of the clever things like rotating and sizes are not allowed in here for a virtual log. That's because the rotating of logs are actually done on the VIOS side of things. We need to restart the syslogd to pick up the new configuration. We do a refresh -s syslogd. If we go to the virtual IO server, same directory as before, except now it's syslog at the end in here. And if we look at all the files in here, we find the state file is as before, and the syslog file is command text. This just means it's plain text file, so we can use cat, tar, page, vi, whatever like to look at this log. I like the tail -f option, and then you can sit there watching the log actually appear in real time. Here's an example of a failed and then an OK telnet session, so login attempt failed and login attempt successful. Now we've already covered enough for you to get the vlogs working and successfully implement a rollout if you wanted to. We've got a few little advanced topics here, looking at some more of the details of the virtual logging commands, the virtual log repository commands, and then a few advanced topics, dual VIOS server, LPM and SSB. We've seen the simple form of using the make vlog command. A couple of extra parameters in here. First of all, we can specify a storage pool if we don't want to use the virtual IO server's disks itself. We can also specify the device name, so rather than vtlog and a number, we can actually give it a name. Personally, I think that will be very confusing unless you very carefully log them in some sort of sane way. We also have some control down in here on the number of log files and the size of each log file, and the same thing for the number of state files and the size of the state files. Personally, I think the defaults, the log files should be bigger and probably more of them. The state files don't actually have much information in them, so they could be smaller and maybe a handful of those. So in this example then we're using 20 log files, each of 200 megabytes, and for the state files we'll have 4 of those but only 10k each. These numbers in here will override the defaults found in the repository. Here's an example of one that I just created, and we'll see we have 20 files in here when we look at the -d option, 200 megabytes each and 4 at 10k. There's also a change vlog command. This can allow us to change the name or the log name used. Perhaps we made a typo, or perhaps we're changing a naming convention. To actually do that, we have to disable the log before we change it and then start it up again. We'll probably have to change the logging devices as well to match. We can also, if we've already created a log and we decide actually that's a bit small and we don't like the defaults that you can see here, then we can actually make them much bigger. There's also a remove virtual log device. No surprises for what this does. By default, it just removes the devices in /dev. By giving it extra options in here, you can get it to clear out all the data if you don't actually want the saved logs. If we move on to the virtual log repository commands, we've already seen these two list commands to give us the details or the overview of the default pool and a shared storage pool if we have one. There's also a change virtual logging repository command where we can change those settings for the size of the files and the number of files, or we can change the path. Instead of /var vio vlogs, we could change it to somewhere else. So I've got a couple of examples down in here of saving the default before the number of files and how big the files are for logging in this case, and it just says updated repository when it's done. We could change the home place for it. This gets it out of the /var file system. You may want to do that. Or if you want to change the settings for the shared storage pool repository, we use the SP option. Let's look at those advanced topics then. The first, the dual VIOS server. In this case, I've got one disk, HDisk 0, but I'm using 2 paths for my client in here, going to Virtual IO Server 2 and Virtual IO Server 1. In here, I'm going to then have my logging, and I want to send the logging files both to VIOS Server 1 over this vSCSI, and a different log in here I'm going to connect up that's connected over the virtual I/O server 2. We'll actually end up with 2 copies of our logs in here in the 2 virtual I/O servers. So this is a bit long-winded, but it's quite easy when you think about it. If we go to our AX LPAR, we install the PowerSC vlogs options. Then we're going to use the ls-path command, and we can see that one disk is available over 2 paths. If we go to the VIOS server, we're going to use the make vlog command, syslog in this case. It just happens to be set up so that it's vhost 6 on both virtual I/O servers, so we use the same name here and here. Then I go to my AX and run config manager, and it says available now in the ls-path the vlog device on the first SCSI port. If I do the same on my virtual I/O server 2, I then go back to my copy of AX and run config manager again. Then we can see I have the second vlog on the different virtual SCSI. And then I'll edit my syslog conf to push a copy of the syslog into both of these virtual logs in here and refresh it. Here's the example of the syslog conf file. Then on the 2 virtual I/O servers, it will look exactly the same because they're identical copies of the log. But on either of them, if I go to var vio vlogs diamond 7, which was my client, and syslog, in there I'll have 2 files in here. I can then look at the syslog file and find the information. In this case, I just started the syslog D and it says it's been restarted. If I then go to my AX image and run a command to output stuff into the syslog file, then I can go and find that again on both virtual I/O servers in their 2 separate copies of the virtual log. Note though that the client has double the number of logs, and we need to configure that twice, so there's 2 virtual logs for this client to virtual machine. Double the data as a copy on each. Now if we use a shared storage pool, we'll avoid that. So what about live partition mobility then? Well, it all works fine. My first attempt worked fine. I was quite amazed. The virtual logs are recreated on the target virtual I/O server or virtualized servers. Those logs on those new virtual I/O servers initially contain this migration of the logical partition log records. We'll have the same files in the same places on the virtual I/O servers, and the client is completely unaffected. It still logs to the same devices, just the data goes to different virtual I/O servers now. But the older logs are still on the original VIO server. They're not copied between the virtual I/O servers. They could be several gigabytes in size or something after a significant amount of time. So we're not going to copy those files, those log records over. So you may have to do some cleaning up or setting up the remote logging again from the new virtual I/O server. Using the VIO server shared storage pool solves this again. Now we're not going to teach you all about shared storage pools, just so this is a different way of connecting our disks up and getting the control at the virtual I/O server level. All the virtual I/O servers in a shared storage pool have access to the same LUNs, and so they can see any virtual log that's created in the shared storage pool. So we'll have the same virtual log before and after the live partition mobility, because when we do LPM of something using a shared storage pool, you can only do it inside the group of VIO servers that are using the SSP. So all you have to do is, when creating on the virtual I/O server the vlog, we add in the -sp and the pool name. In this example here, my pool is called Atlantic, and so I just add that parameter in there. It goes into the different repository that's in the shared storage pool. So if we have a shared storage pool already, this is very simple to set up, and we don't have that problem with leaving bits of our logging behind on old VIO servers. There's just one, and it moves with us when we move our logical partition. Here's an example that I copied from the PowerSC manuals. It's a sort of logical view of what's happening in here. Here we have a client logging to a device, virtual SCSI to the virtual I/O server, and it's logging that into a virtual log in the shared storage pool. When we move the client logical partition to a different machine, it's going to connect to a different VIO server, but this VIOS server has an equal view of the shared storage pool and can see the virtual log that you're writing to, so it just reconnects it up. Now if you're using the dual VIOS server and the shared storage pool, then don't worry, it works it all out for you. You'll be outputting into two logs. It will work out that it has the same UUID, and so the multipathing will end up with just one of them logging into the single shared storage pool log. Well, that's it for trusted logging. Simple to implement and fairly simple to understand. It's a flexible naming conventions, and it piggybacks over the virtual SCSI that you probably already have. And for smaller sites, that may be enough. You've got the logs off the logical partition into your VIOS server. That gives you a great deal more ability to find out what's happening when you've had a disaster or you've been hacked. For larger sites that are already shipping their logs to some sort of log archive, well, that can actually reduce their work because you're going to just set up that connection to the virtual I/O servers, not all the underlying clients. So you're going to save maybe 10 times to 100 times less work to do that setup. I know that some log archive mechanisms can actually just spot a new file coming into existence. This time it will be on the virtual I/O server and automatically start archiving it to make life easier. If you're using live partition mobility, then some further planning is needed because you'll have bits of log files on different virtual I/O servers. But of course, if you're using the shared storage pool, that will fix it. Now, one sort of log file that we haven't covered is the AIX error report. That's the reports that you usually get with the ERRPT command. There's a quick dodge or a fix that you can use to actually convert that to put it into the system log, and then trusted logging can use it. But I'll put that trick into a different movie.